So as many of you know, I just came back from the US. And one of the fantastic things about Canada is Joseph. The MyTax program and the NSERC Alliance programs, there's nothing equivalent in America. And so for people in industry, if you're willing or want to work with academics, or you want interns, you want to try before you buy our students, these programs are just stellar. So I'm going to talk about partnership specifically with the Free Appropriate Sustainable Technology Lab. And we do things slightly differently than most of the other labs on campus, which partially explains our success. Next slide. So we do everything open source. And for those of you that come from kind of the IT world, you're already familiar with this idea. So open source refers to the licensing agreement on the technology. It came from software, and the idea is that if you license with an open source license, everyone can see what you've done. They get to see the technology, and they are allowed to do anything they want with it. So they can copy it, they can modify it, they can sell it. And you might think from a business perspective, like that's just bonkers. But some of the most successful companies in the kind of the internet age are completely run off of open source stacks. So everything that we heard about the great presentation on AI and machine learning, that's all run off of open source software. All the supercomputers in the world are run off of open source software. If you use any internet company, that's open source software. You could still make money on it. A great example is when IBM bought Red Hat for $34 billion. Red Hat's core offering was Linux, which you could download for free, put on your own computer. You could even burn DVDs and sell it at the street corner if you wanted. So there's ways to build businesses off of it, but the reason that we use it in our group and that so many in industry are kind of favoring it, particularly on the software and more so on electronics, is it leads to more rapid innovation. The more people that you have looking at the problem, the more likely you are to get a good success, and the faster and more superior your total overall technology will be. So working with FAST has a couple of these advantages built into the cake. So if you would want to partner with us, instead of waiting to talk to the university lawyers, who are all very nice, but will take months before you start the project. If you shake my hand today, we can start tomorrow. Like there's nothing stopping us. When you're working with us, what you do know is that all the technology that we create is yours. You can do anything that you want with it after we're done, but you have to understand that you have to let my students publish. As long as we agree upon that we're publishing all of our work open source, you get to use all of it. So no NDAs, immediate collaboration. You can use all of our tech. Everything that we do is free. So whether it's books, papers, the software code for the things that we're developing, the hardware designs for what we're developing, the new IV curve tracer that we just have coming out, if you want a copy of it, it's yours immediately. Western University, just to brag just slightly about my students for a second, is a top 1% university in the world. We're consistently rated as one of the top sustainability universities in the entire world. In FAST, I only accept the top 10% of students. So when you multiply 1% times 10%, you're starting to get to the pretty rarefied people. Because of that, we're consistently ranked in the 0.1% of all academics everywhere. And so what you get from that is an enormous amount of output. There's 35 HQP now associated with the group. We publish between 40 and 50 articles a year, many of which are on agrivoltaics. So we have lots of things to offer from different disciplines. So Chris and I worked a little bit on snow analysis. So the first question you get asked generally from a normal person when you say that you do solar in Canada is, well, what about the snow? 3% losses is the answer. It's almost nothing. You can definitely improve upon it, and some of the work that we're doing looking at future forecasting as climate change actually starts to barrel down on Canada is that the only places that really need to worry about snow losses in the future are very far north isolated communities. And so this work is all coming from open source computer vision software that are monitoring panels in real time. We had a great idea, a question a few sessions ago about soiling, and it's like that's something else we need to add to the list. We need to be sticking cameras on vertical arrays to look at what these soiling losses actually are, running it through computer vision and giving a machine learning algorithm so we can get an exact loss and then predict it for anywhere in the country with any type of crop. So that's on my list, so thank you. We also develop a lot of hardware. We develop usually the hardware for ourselves first, and then we make it available to everywhere. So one of the things that you'd like to have at every solar farm, no matter where it is a good MET station. So we have made a low-cost climate station, and there's a high school student somewhere in this room that replicated it in Alberta and has brought another copy of it down here for us to put up again. And so these are very low-cost systems. They cost this slight differentiation in cost depending on whether you want it Wi-Fi or 3G. And it has all the normal great things that you'd have for a commercial system, except at pennies on the dollar. If you're getting really into agrivoltaics and talking about optimizing the type of photovoltaic module that you have for a specific crop, you might want to know its albedo. And so we made this multispectral albedo sensor that uses a bunch of different colors of LED, so that instead of putting an actual spectrometer on that costs tens of thousands of dollars, for this, for $180, you could do a quick scan of your field, of your particular crops, and know what might be the best solar panel that you'd want to apply there. We're building the wired system, the Western Innovation for Renewable Energy Deployment. It's an experimental farm about 10 minutes north of campus, and we have a whole big bunch of systems ongoing now. You've already met Uzair, he's sort of in charge of the technical piece of it, and Kashish, she's an Ivy student and looking at the business side of it. And so all of the FAST lab is extremely multidisciplinary. We have every engineering discipline covered, but we also have a lot of students from Ivy sort of helping us out. We already talked about this great project. This is where we're super excited about this. It's combining agrivoltaics with indoor growing. It just got delivered the other day. We should have this up and running right after Christmas. So I'm super excited to see what we could get coming out of that. We also do all of our own DAC systems. And so if you're doing any kind of data analysis, monitoring, control, SCADA, anything like that, we have a system that is much, much less expensive, and it's made to be completely modular. So we have about 15 cards now. Each card has a specific function, like maybe monitoring temperature and controlling it. And so if you need that for your specific application, maybe you're doing something in greenhouses, you can get one of our cards for like $15, attach it into this I2C line, and then you have complete control over that specific function. More types of things you want control over, you just add cards. We're using it from everything from controlling bioreactors to greenhouses. We already mentioned the computer vision and machine learning thing that we're doing. What we didn't mention, and this is, in my mind, the coolest part, is we're making synthetic images of the crops that we'd like to study. So we build up a Blender model, which is sort of like CGI for making a movie. We then code it, so we're taking pictures of every angle of that, say, strawberry, spinning it around, changing the lighting conditions, changing the background, changing whether it's diseased or not, changing the geometry of the strawberry, then taking those synthetic images and using that to train the machine learning algorithm, what we just proved is 96% accurate. And what we're hoping, maybe, is that we'll get even more accurate. And so if we can get to the point where we can do that for every crop, so building up this initial model is kind of a pain in the butt the first time, and the way that we did it with the strawberries is we went through hundreds of images, which is really tedious and time-consuming and painful. And what we're hoping to do in the future is eliminate that step completely and have the computer do the heavy lifting for us. We've talked a little bit about some of the things that we're doing with trying to find extremely low-cost racking solutions for agrivoltaics. The things that we've been doing with field fences is probably, I don't know if we can go any lower than this. The cost for the rack for a fence that you already have at your farm is 4 metal zip ties. And polar racking is awesome, but it's going to be hard for them to beat that. And so we've done the mechanicals on this. We've done the electrical on this. This is ready to go, and it's already being commercialized in Germany. We also have teams of students working on DC nanogrids. So if, say, on your farm, you don't necessarily, like, say you're doing something small, you don't necessarily have to go big and go grid integration and sell it to Microsoft, let's say. Instead, you could just power the things that you need with the power supplies that you need. And we have a system that basically, sort of almost like Legos again, where you're plugging in what type of electronics you need powered, and then we can provide the circuit for being able to do that. We're also working on generating hydrogen from the excess solar energy, both for storage, so that you could use hydrogen as, say, a fuel, but also for water treatment. So we, Giorgio's working with the other side of ICFAR, which is where the field site is at, on doing water treatment with hydrogen. And then last but not least, Ria is in charge of our life cycle analysis, so she keeps us all honest to make sure that what we're doing actually makes sense from an environmental perspective. And so some of these questions on, as you go higher and higher up to, say, let cattle underneath, and you need more and more concrete on the base, are we still kind of as green as we would like to think that we are? We talked a little bit before about vertical mounted PV panels, which is a brilliant idea and looks really good. And we've always been trying to start off with the small scale. So we always do things in wood first, thinking about what a farmer on a small scale could do for him or herself. And when you try to do signs, the photovoltaic sized with wood, you quickly find out that's never going to make any sense because they have to be super, super thick if you do it conventionally. So trying some crazy ideas, we thought, well, what happens if you put the modules on a simple swing and let the wind blow them out of the way when the wind is blowing and then fall back? And it turns out that, at least in theory, we get 12% more energy letting it do that. So we're going to build these systems, and if it works, then some of the bigger people in this room can commercialize it and go crazy. And that allows you to go to, even if you're not using wood, so you're using aluminum or steel, you can go to thinner members using less embodied energy, less cost, and hopefully a way that we could get more and more systems out on large-scale fields so that farmers can continue doing the work that they're always doing. We also have a team working on building integrated greenhouse photovoltaics. And so Nima has a thermal model. So if you have a greenhouse or want to build a greenhouse anywhere in the world, you give us the specifications for it. He can tell you how much PV you need in order to power it, depending upon the lighting, the HVAC, et cetera, and whether or not you should be consider using partially transparent photovoltaics or those that are spectrally shifting the light in order to be able to get even higher yield. And then Shafqat is working on a system that's even more sophisticated for buildings where you add in a thermal battery. And so you take your photovoltaic power, you convert it to heat with a heat pump and store that in a thermal battery. And we suspect, but we don't know for sure yet, that we'll be able to beat electric batteries on costs this way. You saw a couple examples in other places like Florida where they put photovoltaic modules on the water. And that's an awesome idea. Water cools the panels, increases the efficiency, you stop the water from evaporating. Wouldn't it be cool if we could do it here in Canada? So Kwame already pretty much proved that we can do it here in Canada using last winter's data on some of these synthetic ponds that we have up at the farm. And what we're doing this winter is expanding it very substantially to make a real FPV array. And we're doing it on flexible modules where we adhere foam to the back of it. So it's a very low cost racking solution. We should get the same evaporation loss reduction that we see kind of with other technologies. And what we're hoping is that we can show that this is completely safe for bodies of water. So if you have a farm with any type of water system on it, especially if you're interested in conserving that water, this might be a good solution for you. We are also developing some of our own software. So anybody in here that has built a microgrid probably used Homer software. Really nice software package that NREL developed over decades and then had a spin-off company, and then they locked the code down, and now you can't change anything. And so for someone like me, it drives me crazy when there's something easy I want to do and we're not allowed to do it. So we built Sama. Ali made a new Homer. It is Homer, but with the extra stuff we want. So if you want to do something like machine learning-based predictive modeling, well, Sama can do that. If you want to do just normal everyday Homer, well, we can do that too. So if you're interested in building any type of a microgrid, if you're interested in an off-grid system, if you're doing something up north, Sama is free and open source software. It's getting more capabilities every day. We're working on an electric vehicle kind of plug-in module for it as well. And so anything that you're interested in terms of modeling off-grid, Sama is definitely your solution. If you're interested in crazy ideas, if you have something that you think is completely off the wall, that's the kind of stuff I personally find the most interesting. So we're very, very interested in working with you. And even some of our ideas that I didn't think caught on. So we made this wire-based tension racking system for low tilt angle applications. And so we were thinking maybe Walmart rooftops or people in Ecuador. And we published the papers, and nothing sort of came of it for a couple years. And I was like, that was a nice idea, but I guess no one wanted to do it. And then I checked the downloads the other day. The downloads for that design have been, somebody has bothered downloading it 20,000 times. So somewhere in the world, there's a bunch of these systems, and I see pictures on the internet every once in a while, but it's an open source system that you can build with a 3D printer and some cabling, and you're off to the races. We already talked about the awesomeness of the MyTax program. I can't say enough about how good that is. If you are interested in working with top students, whether they're mine or somebody else's, it's a spectacular project, the way to get your research funded, and if you couple that up with an NSERC, it can get very interesting indeed. So last but not least, especially for small farmers in the room anywhere near London, I have free solar panels, and I mean free as in like no money solar panels. So I had this idea where I wanted to set up kind of like the Disney World of agrivoltaics, where we just try everything, throw it on the farm, be crazy. And we're going to do that. But as we started to build this out, what we realized is that we don't have a ton of experience in farming at Western. And maybe if I was at Guelph, things would be different. But you, the farmers in this room, actually know what's going on. And so if you are interested in trying some of the new types of racking designs developed by us or some of the commercial partners, if you want to try different types of modules that have never made it onto the Canadian market, we are very interested in working with you. So the way that it will work is we'll provide the designs and the modules. You will provide the funding to get the system integrated into your farm, to maybe power your farmhouse or a specific location. And we'll also give you a DAC system. You have to allow us access to your farm to kind of collect the data and play around with it. And we would like your help in sort of doing things like yields and collecting some of the food products so that we can test them here in the Biotron. And so here's some examples of the things we want to play with. These are partially transparent modules on purpose, where they've basically left out the back sheet and not put as many cells in a typical module, of different levels of transparency, 69, 45, and 8 for conventional modules. For looking at thin film modules, we have transmission going from 10 to 80% by tens in blue, green, and red. And so you have all different kinds of things that might be an optimal for your specific type of plant. And then we have these modules that were made specifically for greenhouses, but that doesn't mean that you have to use them just for greenhouses, where we are spectrally shifting the light to something that's more applicable to help plant growth. And so we have a couple different transparency values for these as well. And I already have a pre-approved agreement. So you literally just put your name and address in, and we figure out what we're going to do, and it's ready to go. So we could probably pull these off this afternoon if you're very interested. It would be pretty fun to see how fast we can get it through, because everybody's agreed on everything already, so now it's just a matter of sending the paperwork through the university. So overall, we are very, very interested in doing MyTax internships for my students, many of whom are international students that are interested in staying in Canada permanently. They want to be employed by you. They want to work for you. They're the top students anywhere in the world. We can do alliance things. We can do experiments on your property with the modules that we already have in hand. For anyone, whether you're an academic in here or an industry partner or the government, if you are interested in things that are open source, that overlap with what we do, we're very interested in working with you. So if you have a new type of farming equipment that you want to see powered with solar, we would like to do that with you. If you need open source computer vision and AI related to agrivoltaics in any way, we're definitely open for business there. We're interested in policy development, maybe doing the heavy lifting on something like Canadian policy, I don't know. Rapid prototype and distributed manufacturing, that's the other half of my lab. We have the DAC system that I already talked about, and then we have a lot of open source rack ideas that we would like to see commercialized and kind of brought up to snuff by the professionals in the room that really know how to do these things. And so without further ado, all of our work is free. And if you're interested in anything that we've done ever, it's on appropedia.org/fast. It's all there kind of laid out. And I'll stop here. Thank you very much for your time and attention.